Hello and welcome back to the shop. Obviously this is the beginner video for internal threading, and it's coming to you a little bit later than usual, than I promised. And that's because when I first started filming this, I lost about half my video on my camera. My camera just froze as I was recording and I didn't realize it. And it didn't record half the footage I was doing on the lathe. And then once I got that all figured out, retaped that section when I went to go transfer from my camera to my computer, it got lost there. So I don't know what the hell happened. Hopefully I have everything figured out now. I don't know how the hell that happened. I mean, well, you got a tiny little card that holds 9-hour videos. I mean, I never lost anything off of one of these suckers right here, unless you count the time that I accidentally taped over Christmas 1988 because I wanted to record that MacGyver special because he really thought he wasn't going to get out of the jam that he was in. But that was my own stupidity. So obviously we're going to be doing internal threading, and we're going to be using these little PVC couplings here as the example. And just because they're a lot cheaper to use than trying to cut a ton of metal. So I'm going to be using these for the demonstration. So we're going to come up on the table here, and I'm going to show you some of the tools that you're going to need, which is mainly the same as the external threading, just a couple of different things, and how we're going to go about the measurement side of things a little bit. Now again, this is just going to be cutting the thread. This isn't going to be actually measuring the thread. We're going to cut the thread to fit a male example. And we're going to be cutting a straight through thread. I'm going to be threading straight through this piece, which is the easiest one to do. And then we're also going to be threading up to an internal shoulder, which is a little bit more difficult, but there is a couple of tricks that can get you around that. So let's zoom in on the table here and show you some of the tools. Okay, so a lot of the tools are going to be the same as we had with the external threading. So we're going to need, you know, one of these thread checkers here to check and make sure we're on the right pitch that we want to cut, and we can check what pitch our nut is, or our male thread is that we want to match. You're also gonna need the little 60-degree thread gauge, which is pretty much standard. Now, something a little bit different, since we're actually doing a bore, you have to accurately measure the bore. Now you can use regular calipers to do it, but if you need a finer measurement than that, you can get an inside micrometer, which are kind of expensive, or you can get yourself a set of these telescoping gauges. And the ones that I have are the ones that are that adjust on both sides. Some of them have a fixed leg and only one spring leg. These ones happen to have two. I like these a little bit better because if you're on the outside or inside range of these, you can center this up in the bore as best you can. Usually with the ones that have a fixed leg, if you're at the smallest range, you're kind of limited on that extra spring leg as far as clearance goes. So we have those, and we'll show you how to use those. Again, you can use a caliper or something, but if you need finer measurement, that's the way to go. Also, you'll need your 60-degree threading tool. Go back and check my previous threading video where I show you how to grind we actually ground an Acme bit, but the same process applies to a 60-degree threading bit. And this is just held in one of those boring bars that take the 1/4-inch tool steel. So now you can see obviously it's shortened, and this is off of a regular 3-inch blank, and it's just cut off with one of those fiber discs on a Dremel tool. They work great for that purpose. Just cut right through it, round off the edges, and fit it in the bar. Now obviously you want to use the largest diameter bar as you can, that you can fit in the bore. In my case, I'm using the smallest one that I have just for camera purposes. It's a lot easier to see in there. And also you have to make sure that your tool bit, when you grind it, that you have enough room for this to fit in the bore. You might need to trim it. Now the other thing is the smaller the bore gets, the more chance you have to run into the actual heel of your tool. So sometimes you may have to round off the edge of this to get your clearance around the inside edge of this. So if this is approaching the work like so, the smaller the bore, the tighter this curve here is going to be approaching your tool. So if it's too close and you're rubbing, what you might have to do is grind and nick the edge off of that. Okay, in this case I have plenty of clearance. And you're also going to need an internal grooving tool, something along the lines of this. And this is for going up to a shoulder if you need to make the relief groove for the shoulder. Now the one I'm going to be using is going to be exaggerated. It's actually got a 1/4 inch square ground on the end of it, and that's just for, you don't need anything that big, you just need enough clearance for your tool. The reason why I'm making it that big is just so it's exaggerated, it's easier to see on camera. And that's about it. Now what we're going to be doing is we're going to be taking this reducer here, and we're going to be threading it to fit this cap. So we have to take some material out, and then we have to thread this. Now these are tapered threads, but what I did is I just measured the minor diameter of this, and then measured what the actual taper is on the threads, and we came out with a happy number of 1 3/4 is what we'll be making our bore, and that should allow this to thread in roughly halfway. We're just using this for a test piece. Now here's the thing, if you have an 1.5 thread here, or sorry, an 1.5 thread, and you want to thread something to fit over this, okay, which is this, you can't just plug an 1.5 hole into this, because you have, let me zoom you in here, what you have here is you have your major diameter, which is the crest of your threads, and the minor diameter or root is this smaller edge in here, all right, these valleys. So if you have an inch, this is an 1.5 threads, meaning your major diameter, your outside here, is an 1.5. So if you make an 1.5 hole in this, you have no thread engagement, okay? So you have to make it smaller. You have to make it enough, basically your minor diameter. You have to cut your hole in this to the diameter of those valleys, okay? And how do you determine that? Well, there are plenty of charts available. Machinery's Handbook has them all, and they will tell you. So American Course Class 2, here we go. So if you look down here, let me zoom you in a little bit. Pitch diameter we don't have to worry about. Major diameter is the outside diameter, we don't have to worry about that. We want our minor diameter, and you can see there's a minimum and a maximum. So for 1.125" we have a minimum of 0.8647 and a maximum of 0.8795. So it does give you a range. Now that range depends on class of fit, which we're not even going to touch upon in this video. So that's how you would find your minor diameter. Now also I want to point you to Little Machine Shop there, and if you go into their document section, you can see I laminated this one, but they give you a nice chart, and it gives you a whole range of screws, and it gives you your major diameter, your what you want for threads per inch, it does fine and coarse, and it tells you what your minor diameter is. Now these are all for a class 2 fit, and like I said, we're not worried about class or anything like that. Plus it also tells you what your tap drill is and what your clearance hole sizes are, all in one chart. So it's a very good resource if you don't have a machinery handbook or don't want to refer to that chart all the time. Plus this is a lot bigger and easier to read than those little things. So like I said, for us, our minor diameter on this is going to be 1 3/4. So let's go over to the lathe, we'll set one of these up, and we'll bore it straight through for an 1 1/4" diameter, and that's just going to be straight through it. The first thread we're going to be doing is going to be a regular thread, straight into the part, straight through from one end to the other. And then the second thread we'll be coming up to an internal shoulder that we'll make, and I'll show you how to deal with that. Okay, so first things first is we have to take this down to 1 3/4 inches. So we actually have 80 thousandths to remove from here. So I'll probably take 60 thousandths, and then we'll measure with the calipers, and then we'll go from there with the micrometer and the telescoping gauges. So let me get some speed on this lathe. I'll set this on center height here. Okay. Okay, so a little bit of a rough surface there, way too rough to measure, so we'll just take a little bit. Clean that up. Okay, and get a good measurement on that. So we're going to start off with the calipers there. Oops, sorry, I didn't mean to nudge you. Alright, I'm reading 725. So I'll take 20 and then we can start using the micrometer. Okay, so the way these work is you want to get them in the center. You want to where are you? Loosen up the locking handle, squish it together, and then tighten the locking handle again so that they stay. Get it in there, loosen the knob, and then they'll split apart. Okay. So usually I put the larger anvil on the bottom, eyeball it so it's roughly in the middle of the bore there, and then we're in the middle this way too. It should center itself up pretty good. Kick one side out, so either kick it towards you this way or kick it away from you. Okay, I like going away from you. I like going away from me. So kick it at an angle, tighten down that knob, and then plant the bottom or the larger anvil and rotate the whole handle out. Alright, and you can see that it held its shape. And then, zoom you out again a little bit, you can see that it held its shape there. So now that is the bore of this. So then take your micrometer and you want to mic over over those anvils. So you just do it by feel. Try to see if I can get this in the camera frame. So you do it by feel. Get the micrometer in there. Usually I put the larger anvil on the non-movable side of the micrometer. Alright, get her in there and then just move the mic around. It's easy to do it really close to your body. I'm just doing this to kind of demonstrate it on camera. But move it around and you'll start to feel that anvil come in contact. Right there, it's kind of skipping. Let me get it closer just so I can get it a little bit more accurate. And you'll be able to feel it. So right there, it's skipping. And that has given me 1 inch 352 thousandths. So if I really wanted to, I can take those extra 2. So we will, just because we can. Do the same thing and I'll leave you out there. So squish them together, tighten the locking handle, put it in, loosen it till they snap out, tilt it away a little bit, tighten down the handle and rotate down, and then again compare to the micrometer here and see what we got. So right now we're at 1 inch. .723. So I took a little bit more than I needed, but that's plenty good. It's only 2 thousandths shy, which is perfectly fine. Now again, you saw in the book they'll give you a range to hit, so we're obviously within range. So now I'm going to take you back out and bring you up high, and we're going to set the compound and get the tool bit all squared away. Okay, so we have our tool bit in the holder. It's set on center height and it's set level. And now we got to set our compound angle. Now, compound angle is always half of your threading angle. So in the case of 60-degree thread, which is what we're threading, we want the compound at a 30-degree angle, which is where it is, which is where I usually keep it. But here's the problem. This is set up for an external thread. Okay, so an external thread will be feeding this way, and we'll be feeding our tool bit in towards the work in that direction. So the compound feed, as you can see, it diagonally feeds this way. So we'd be cutting on the front leading edge of our tool during external threading. All right, we'd be cutting on the outside edge of that tool as we feed in a little bit more and it'll go in. We can't do that this way because we're going to be feeding the tool out towards us. So if we do that, you can see it's actually moving the cutting edge back this way. So we'd be cutting on the back edge of the tool bit. We don't want to do that. So we have to swing this compound around either 30 degrees this direction so we can get the feed here at this angle here, or all the way over here and feed in this way. We want the feed of the compound the same direction as the feed of our carriage, so we're always cutting on the front edge of that tool bit. Now here's another trick. When you're doing that, you're going to be feeding in this way, you're not going to be able to see what you're doing, which is not really that bad when it's a straight through thread, okay? Straight through a piece, because you really don't need to see what you're doing. You just need to pay attention to your dials. But if you, for whatever reason, you do need to see what you're doing, now remember, our part is rotating in this direction, okay? If you do need to see what you're doing, you can take your bit out and mount it upside down, okay? So that the cutting edge here is pointed down and mounted in like that. Now you're feeding in on this side of the part, okay? And you can see in there, your part is still rotating in this direction, so as you're feeding in this way, you're hitting the cutting edge of the bit on the which is now on the bottom, okay? And you can actually see your cut as you go. But like I said, we don't need to, so I'm just going to leave it like that. Alright, so we need to swing this compound around. Now it's easier for me, there's no zero on this side of the compound, so the only zero is here, so I'm going to have to swing it around in this direction here to see the 30-degree mark. But I mean, if at all possible, if you would rather have the hand wheel over here, you can also do that too. And just make sure, obviously, your compound doesn't interfere with your chuck jaws. Alright, so now we have to get this tip of this tool perpendicular to our work. So there are a few ways to do that. If you have a true turn surface on the outside, you can lay this gauge out against the outside edge and use that as your flat reference spot. Now you wouldn't have to do this if you had a carbide insert threading tool, because obviously that cutting edge is always 180 degrees or 90 degrees rather to the bar, so you would only have to make sure that the bar is straight, which you can do by squaring up against a chuck. But this is a hand ground bit, so we're probably going to be off a little bit. So like I said, if you have a true outside surface, you can use that as your reference point. If you can get inside and hold it like that, you can use the inside surface as your reference point. And also, more than likely, you're going to have a nice flat faced finish on the front here. You could put a scale across the edge and use the little feet and have that as your reference surface to square yourself up. So I'm actually going to use the inside here because it's easy for me to get my finger in here, just like that. And we'll just make sure that this tool is perpendicular to our workpiece. Right, that looks pretty good. Okay, I don't know if you guys might not be able to tell from that angle, but I can tell that this bar is cocked just slightly that way to get this perfectly straight. So this grind isn't perfectly in the center of that bit, which in all honesty doesn't matter as long as it's at 90 degrees to the surface, as long as it's perpendicular to whatever we're cutting. So now we're ready to cut. I'm going to change the angle. Oh, but actually before I do that, the thread on this is actually an 11.5 pitch, which is which I can show you something else. The threading dial on this has 1, 2, 3, and 4, and then in between those is a line. So it's 1, a line, 2, a line, 3, a line, 4, a line. Okay? Now, if we were cutting a regular even number of pitch, like a 12, we could choose any number or line. But we have kind of an oddball thread of 11.5. So we can only engage our half nuts on our odd numbers. So we can only engage the half nuts on 1 and 3. And that's it. Okay? So I'm going to put some bluing in here so we can see what's going on while we're cutting and hopefully get you a nice angle. Okay, so we got you in a pretty good position. Sorry about the shake there. And we have our gearbox set to 11.5 threads per inch, which is on this lathe. The left tumbler is in the A and the right tumbler is in the 5th position. So we're going to come in here and we're going to get our cross slide here in a comfortable position where we're good with disengagement. Right there. I'm going to set 0, and then we're going to turn the lathe on here, and we're just going to, with the compound, bring our bit in until we touch, okay, and then we're going to set 0 on the compound. Now there is an 11.5 threads per inch on the thread gauge here, but there is 11 and 12. And 11 is 118, 12 is 108. So we'll probably be somewhere close to there. So when we get this, probably when we read in the 90s, we may start checking our thread, and it'll all be done by sight and everything else. So right now I'm only going to take a 1 or 2 thousandths depth of cut. Now you do have to beware that you're actually feeding out, so you're backing out the compound, not feeding in. Just be aware of that. And we're going to turn this lathe on. I'm going to wait for the odd number to come around, wait for 1 to come around. Disengage the regular feed. Alright, we caught it. And we're just going to make a pass. And feed in, come back, and reset to my 0 so we don't forget. Now I'm just looking for the tip of that tool to come out where I can see, right where the scale is. I'm just looking for the tip of the tool to come out there. And then that's when I'm disengaging my feed. Like I said, this is easy because you're going right through the pot, so you have plenty of clearance. So we're going to take our gauge here and just make sure we're threading 11.5 threads per inch, which I'm trying to do it backwards and in the camera so you guys can see, but it is. And we're going to start threading. So we'll take 20 on the dial. Actually, we're going to take 40 on the dial because this is just plastic. Okay, it's poking out. I can see it. Feed in 1 full revolution, come back to the beginning, and then come back to the 0 on the cross slide. Take another cut. Gotta wait for the 3 to come around. Okay. And you can see we're right in that same groove. Wait for it to come out the end. Feed in 1 full revolution. Come back. Set 0. Take another cut. Back to 0. Take another cut. Waiting for the odd number. Alright, so that's 80 thousandths
on the compound dial there. Okay, so you can see what we have left there. And we should start to thread, but we should be tight. Okay, yeah, it's starting to thread, but it's tight. So, go in a little bit more. Okay, that was 100 thousandths on the compound. Now that isn't 100 thousandths depth of feed because we are feeding in at an angle. But what I'm going to do right now is take a spring cut, and this will take out all the slop in that boring bar. It'll take out all the spring and the tool pressure. So you can see we're just removing just a little bit. And that's how much flex was in that bar as it cut. You can still see, I don't know if you guys can see, some traces of the purple right on the crest of those threads. Or the bluing, and so blue it's purple. So yeah, that fits in there nice now. And we're halfway on the threads. Okay, so now again, these threads are tapered. We were kind of shooting to be about halfway up on these threads. And you can see we fit in there pretty much until halfway. So not the perfect example, but obviously you would want that to pass all the way through. But you can see that's our thread depth there, and that's what it looks like. And you can see, if I can get this to focus a little bit, if it shows up on camera or not, but there's still just a trace of the bluing right on the crest of those threads. You can see it a little bit better right there and there. Okay, so that's a regular internal thread, and that is straight through the piece. Now the next one we're going to do, let me grab the fitting. The next one we do here, we're going to come up to that internal shoulder. So all I'm going to do off camera here is I'm going to bore this to the 1 3/4 up until that shoulder, and then I'll show you how we kind of take care of that. Okay, so now we got this hole to 1 3/4, and you can see the shoulder we have in there. Now we have to put a relief groove in here, and that relief groove only needs to be the width of our tool tip that we're using the thread. I'm going to make mine like a 1/4 inch or so, just to exaggerate it, just so it's easier to see what I'm doing, just from the camera angle. And so we just got to bring our tool in here, and then bring it in. And all we're going to do is we're going to bring it in there, and we're going to feel it touch that shoulder. I'm actually just going to take a couple of thousandths off of that shoulder just to get the bluing off, so it's easier to see for you guys. And we're going to make a relief groove. Now the relief groove only has to be as deep as our threads are. So go ahead and do that. Here. make sure everything looks okay for you guys to see. Yeah, it's got a little bit of a buzz on the end there. Okay. Clean that up for you guys to see. All right. So you can see we got the relief groove in there. And that's what we're going to be starting our tool in. So I'll highlight that with a black marker so we can see the inside edge of that, and then I'll set you up at another angle to show you how we're going to set this up. Okay, so now we have to thread and we have to deal with that relief groove in the shoulder. So we want to stop this tool in the relief groove before we hit that shoulder. So there are a couple ways you can go about this. First way is, actually all these ways would require a carriage mount indicator or a DRO. So what we can do is get the tool in there, right in that relief groove, and set our 0 on our carriage mount indicator, and then thread like we just did and disengage at 0 every time. Now there's a problem with that in the fact that if you're a little slow, you can mess up, miss your 0, and either be still in your thread or hit that shoulder by accident. So there is a way to get around that. And what we can do is we can take our tool bit out of here. Okay, now we can do two things. We can either put it in opposite like this, or we can flip it upside down like so. And now what we're going to be doing is running our lathe in reverse. Okay, so we're going to be running it in this direction here, and we're going to be feeding out. So that way what we can do is, again, get the tool tip into our relief groove, set 0 on our indicator, right? So we're going to start in the thread relief, and we're going to thread out towards the chuck. We have to be rotating backwards. We have to be rotating in the opposite direction we were, because if we don't, we'll be cutting a left-hand thread. So you can either cut upside down like this towards you, or you can thread with the tool bit right side up on the opposite side of you. Now if you're in that direction here with the tool tip up and threading against that side, your compound will have to be pointed in this direction here, because again, we want to feed into the work at in the same direction as we're feeding the carriage. We're going to be doing it upside down in this way because it's easier for me to film that way. And so I need to switch the compound around 30 degrees this way because we want to feed back out towards us in the direction of our travel. Okay, so I'm going to get this set up into center height again and get this squared away down to 30 degrees. Now there is one very, very important warning I have to warn you about. You have to be extremely careful when doing this with a lathe with a screw on chuck with a threaded spindle, okay? Because you're rotating in the opposite direction that you thread the chuck on. So your tool pressure is going to be wanting to stop the chuck, and your thread will want to stop and actually unscrew your chuck, which will be terrible. You'll have a really bad day. So you can do it on a threaded spindle chuck. You just have to be super careful, take very light cuts, and be sure to make that it's not a really grabby material. Again, if you have a cam lock spindle or a taper lock spindle, you don't have that issue. But with the threaded spindle, you have to be super, super careful with threading anything in reverse like this, because you definitely can disengage this chuck from the spindle and ruin your day really fast. So I'm going to spin this around to 30 degrees this way. I'm going to get this back on center height, and we'll get this perpendicular to the piece just like we did before with the gauge. Okay, so this bluing here is where we're going to be cutting the thread. The bluing on the top is the top of the shoulder, and then the black is the face of the shoulder. So what we need to do is we need to come in here, and we just need to, you know, set our compound here at a nice comfortable position. We're right there, seems pretty good. And we're going to come in to the back here, and what we're going to do is we're going to use the cross slide here to just touch. Now we'll be using a mirror or whatever we need to do to see that, but we want to touch. Okay, so there's that touch. And we're going to bring ourselves into that thread relief, and depending on whatever tool we're using, we know, right, I'm using the camera to see, so there's one side of it. And there's the other side. So we want to split the difference to pretty much be in the middle of that thread relief. Now obviously if we use the grooving tool, we'll know the width of that grooving tool. We can just touch and then come in to the back there. But now we're in place where we need to be. We're going to set, I'm going to make sure our carriage indicator's in place, make sure everything's nice and tight. And we're going to set our 0 right there. Now we have to come to that same spot all the time. If we don't, then we'll end up with double threads. So we have to come back to that spot every time. That's where this dial indicator on the carriage comes into play. You can use a carriage stop or whatever you have, but this works out pretty good. So we're going to be running in reverse here, and I'm going to move mine. Threading here. Okay, and we're going to make a test cut. Okay, and then we're going to feed in. And we're going to check and make sure we are at 11.5, which we are. And then we're going to come back right to our 0 again. And then we're going to come back to our 0 again here. And now we're going to make another cut and make sure we fall right into that same groove to prove that we're doing this correctly. So we'll come back to our 0. Take a cut. Now we have to be sure as we feed back, our tool is going to be moving that way a little bit. So you're actually better off starting closer to the thread relief this way, because as you feed back out, your tool's moving a little bit that way. You can figure out how big you need the relief groove or whatever by thinking, but we have more than enough room there, even being in the middle. So we're going to wait for the 3 to come around, and you can see we're right in the same groove. Feed in, come back to our 0. Zero this way, and we'll start taking our heavier cuts. Like I said, you have to be careful with this, because you can spin your chuck off if you're not careful. So you can see we're still in the same groove. Let's see how that goes. Hey. Alright, and that thread's all the way in. I'll be right back. Wife just called. Gotta go kill a bug. Alright. Buggy's dead. Crisis averted. Let's just go over to the bench real quick. Take a quick peek at what we did. And go from there. Okay, so that's a quick lowdown about internal threading. So here's the first one that we did. And we thread on there nice. Again, these are tapered threads, so that's why it locks up like that. And this is the one to the shoulder. So you can see the shoulder in there, the relief groove. And you make that as wide or as shallow as you need to. And this thread's in there. Pretty nice. I couldn't get it all the way down to meet the shoulder, but you know, just as an example, that's two ways of doing it. And the biggest thing, if you're threading backwards in the lathe with the lathe running backwards, you know, I can't stress enough that if you have a threaded spindle, just be extremely careful, because if you take too big of a bite, that chuck is going to come off. I can guarantee you that, and I've come close to doing it once. What you can also do in here, what's a good idea, is take the threading tool again, is come in here into the back of the threads and just make a little chamfer, because you're going to have a really thin thread end of the thread right there. You can see where that's kind of torn out. So just come in there with the threading tool and run up against the threads and just give a nice chamfer to that edge and just clean that up. And same thing with the outside edge. But other than that, that's kind of the basics of internal threading. You know, it's a little more complicated than external threading, and it's a lot more daunting to beginners than external threading. But you know, once you get the hang of it, it's just as easy, and you can create any kind of threaded connectors you need to. Okay, so after this video goes up and is up for a couple days, I will put another video up, and that will have the choices for the next beginner video. We'll come up with a couple of decisions of what we're going to do. We're going to carry over the one that didn't win, and we'll think up another one, which may be another thing to do with threading. Kind of keep on that subject maybe. And so we'll go ahead and do that and have you guys vote on those. So thanks for watching this video. I hope you guys enjoyed it, and we'll see you on the next one.